Welcome to Chapter 6, Exploit and Pivot. Now that you've identified and analyzed vulnerabilities, it's time to exploit them and move deeper into the target network. In this chapter, you'll learn how to exploit vulnerabilities using tools like Metasploit, escalate privileges, establish persistence, and pivot to access systems that weren't visible from your initial position. Let's start with the fundamentals of exploitation. Once you've completed your vulnerability assessment, the next step is choosing which targets to exploit. You'll prioritize based on severity, CVSS scores, the goals of the penetration test, and your own skill set. Most testers target the most vulnerable systems first to gain a foothold that can provide further access. Consider a system with 19 critical vulnerabilities, dozens of medium issues, and several low-severity findings. That's a tempting first target. In our scenario, we're using Metasploitable, an intentionally vulnerable virtual machine designed for practice. Metasploitable comes in two versions. Version 3 automatically builds Windows Server 2008 and Ubuntu Linux virtual machines, though the build process can be challenging. Version 2 offers a direct download and is perfect for basic skills practice. Remember, never expose these vulnerable systems to untrusted networks. Now let's talk about the core exploitation process. When you've identified a vulnerability, you need to find compatible exploits. In Metasploit, you can search for exploits targeting specific vulnerabilities, review their reliability ratings, and select the most likely to succeed. The exploit process follows a clear pattern. First, search for exploits matching the vulnerability. Then select the exploit module, configure the target and payload, and execute the attack. The payload you choose depends on your goals. A reverse shell connects back to your system, which is ideal when firewalls block inbound connections. A bind shell listens on the target, requiring you to connect to it directly. Once the exploit succeeds and you have access, your next steps are critical. You need to assess what you can see from this new position, look for other targets, and consider how to maintain your access. This brings us to post-exploitation, where the real work begins. After gaining initial access, you need to establish persistence. Persistence ensures you can return to the system even if your current session is lost. There are several methods. Scheduled tasks and cron jobs can be configured to reconnect at regular intervals. This is often more subtle than running a persistent service, as it doesn't leave a detectable process running constantly. Creating a new user account is a straightforward approach. On Windows, using tools like Metasploit's MeterPrinter, you can add a user and elevate them to administrator with simple commands. On Linux, adding a UID 0 user provides root-level access. Installing backdoors and Trojans provides ongoing access, though they're more likely to be detected by anti-malware tools. A more subtle approach is replacing a legitimate service with a vulnerable version, then re-exploiting it. Reverse shells and bind shells are both important for the PenTest Plus exam. A bind shell listens on a specific port on the target, allowing you to connect to it. A reverse shell connects from the target back to your system, which is useful when firewalls block inbound connections. Daemons and services can also provide persistence. Injecting malicious code into a running service via MeterPrinter is harder to detect, but a properly installed service survives reboots. Now let's explore how to move deeper into the network. Pivoting and lateral movement are your primary tools for expanding access. Lateral movement is the act of moving from one compromised system to another at a similar privilege level. You're taking a sidestep from your initial foothold to access adjacent systems. Pivoting is broader. It means using a compromised system as a jumping-off point to gain a new perspective on the network. Once you're inside a DMZ server, you might discover internal systems that were completely invisible from your external scan position. Common lateral movement techniques include credential dumping with tools like Mimikits, pass-the-hash attacks, and using built-in tools like PeaceAZ, WMI, and PowerShell. The concept of living off the land means using tools already present on the target system rather than deploying your own. For pivoting, tools like Shuttle, proxy chains, and Metasploit's routing features allow you to route your traffic through the compromised system to reach previously inaccessible networks. Let's talk about privilege escalation. Privilege escalation comes in two forms: Vertical and horizontal. Vertical escalation means gaining higher privileges, such as moving from a standard user to administrator or root. Horizontal escalation means moving to other accounts at the same privilege level to access their data or rights. Common escalation methods include kernel exploits, which are frequently used for vertical escalation on local systems. Application and service exploits target the account services run as or business logic flaws. Database attacks leverage SQL injection or database software vulnerabilities. And design or configuration issues can allow escalation when accounts have more rights than expected. For Linux systems, GTFO-beans is an invaluable resource for finding built-in binaries that can be leveraged for privilege escalation. Now let's cover data exfiltration and covert channels. Once you've accessed sensitive data, you need to get it out without being detected. This is data exfiltration, and defenders are actively watching for it. Covert channels are techniques that hide data transfer within seemingly normal traffic. Steganography embeds data in images, audio, or video files. DNS tunneling hides data in DNS queries. ICMP can be used as a covert channel by embedding data in ICMP packet fields. Other exfiltration methods include sending data via HTTPS to innocuous sites like GitHub or social media platforms, using email accounts that aren't business-related, leveraging cloud storage services, or using alternate data streams on Windows systems. The key is making your exfiltration look like normal traffic. Small transfers of encoded data via HTTPS to a common website are far less suspicious than large SH transfers to unknown hosts. Finally, let's discuss covering your tracks. After exploitation, you need to clean up evidence and conceal your activities. This includes removing tools and files, managing log files, and hiding your communications. Empty log files are more suspicious than modified ones. If the organization uses remote logging, you may not be able to remove all evidence, and the discrepancy between local and remote logs can indicate compromise. Most practitioners modify logs first and only wipe them as a last resort. Concealing communications is equally important. Use encrypted connections, common protocols, and route outbound traffic through innocuous hosts. A direct RDP connection from your workstation after performing scans is likely to be detected. Advanced techniques include fileless malware that injects into running processes rather than leaving files on the system, packers and polymorphic tools that change code to avoid detection, and using built-in system tools to blend in with normal activity. Let's summarize the key takeaways from this chapter. Exploitation is the bridge between vulnerability assessment and post-exploitation. You match discovered vulnerabilities to known exploits, prioritize based on reliability and impact, and execute attacks using tools like Metasploit. Once you have access, post-exploitation begins. Establish persistence through scheduled tasks, backdoors, user accounts, or services. Use reverse shells when firewalls block inbound connections and bind shells when you can connect directly. Expand your access through pivoting and lateral movement. Use compromised systems as jumping-off points to reach previously inaccessible networks. Leverage credential dumping, pass the hash, and living off the land techniques. Escalate privileges both vertically and horizontally. Kernel exploits, application vulnerabilities, and configuration issues are common paths to higher access. Exfiltrate data using covert channels. Steganography, DNS tunneling, ICMP, and HTTPS to common sites are effective methods for moving data without detection. Finally, cover your tracks. Clean up tools and files, manage log files carefully, and conceal your communications using encryption and common protocols. These post-exploitation techniques form the core of what makes a penetration test effective. Finding vulnerabilities is just the beginning. Exploiting them, maintaining access, and moving deeper into the network is where you demonstrate the real value of your testing.